In this video, I will illustrate with an example how to use the definition of integral to prove that a function is non-integrable. In the previous video, I already presented an example of an integrable function. I will work with the function g, defined as g of x is 1 if x is rational, and g of x is 0 if x is irrational. This is sometimes called the Dirichlet function. I want to study the integrability of g on the interval from 0 to 1. I will use the definition of integral. This means I will calculate the lower integral as the supremum of all the lower sums, and the upper integral as the infimum of all the upper sums. These upper and lower sums will be taken with respect to partitions of the interval 0, 1. And the function g is integrable on 0, 1 if and only if these two quantities are equal. I assume you already knew this definition. If you didn't, or if you need a refresher, watch the video where I first introduced it. It's linked in the description. The whole analysis is based on one key observation. For any real numbers a and b, with a less than b, the interval from a to b contains both rational numbers and irrational numbers. If necessary, pause the video and convince yourself that this is true, because everything else is going to depend on this observation. Okay, how does this help us? Consider any partition P and then look at any subinterval from this partition. On every subinterval, the infimum of g is 0 and the supremum of g is 1. Why? Because every subinterval contains a rational number, where g takes the value 1, and also an irrational number, where g takes the value 0. And then what? The lower sum for this partition is the sum of the areas of the lower rectangles, but all the lower rectangles have height 0, so the lower sum is 0. On the other hand, the upper sum is the sum of the areas of the upper rectangles. All the upper rectangles have height 1, so their joint area is 1. And this is true for all partitions. All partitions have lower sum 0 and upper sum 1. Once more, if necessary, pause the video to convince yourself that this is true. Now that we know this, the rest of the calculation is simple. The lower integral is the supremum of the set of all lower sums, but that is a set with one single element, 0, so the lower integral is 0. And the upper integral is the infimum of the set of all upper sums, but that is a set with one single element, 1, so the upper integral is 1. The lower and upper integrals are not equal. By definition, g is not integrable on 0, 1. And hence the integral is undefined. We're done. As a side note, for those interested in analysis, there are alternative ways to define integral. In some of those alternatives, the function g from this video is integrable. The definition I have been using is the Darboux integral. There is a second definition, Riemann integral, which looks different but is equivalent. There is a third definition, Lebesgue integral, which is much more complex but also more powerful. The Dirichlet function, the function g in this video, is Lebesgue integrable, but that is beyond the scope of this course, so I will stop here.